method, hash code, and equals method. And of course, there's a lot of boilerplate here. If there is any kind of unique logic, it's hard to find it. If we want to refactor the class, for example, if we want to add a new field, then we need to manually go over the constructor, the hash code, the equals method, and modify them. So, and for all this work, we get only a very simple class. This is the same thing in Scala. So Scala is a mechanism called case classes, where we define only the attributes of the class, and the compiler will generate the getters, the constructor, the toString, the hash code, and the equals method for us. Here, for example, we see the group case class. It has two attributes, a name of type string and a URL of type URL. It's also serializable. Of course, like any other class, if we want to add our own methods, we can. And of course, if we refactor, if we add a new attribute, then after compilation, all the methods are up to date. But case classes are more than just getters and setters. Here's a code snippet again. First in Java, we want to copy a group and set the name to the capitalized version of the original group. So this is how it is done. We need to implement clone and then call clone and use the setter using a utility method. Again, the same code in Scala. So we have the copy method, which is automatically generated for us for case classes. And we say that we want to copy the group, specifying that the name should be the group's name, capitalized. We see first we have named attributes, so we can the named arguments, so we can specify arguments according to the name and not just the position. Then we get the group's name. This looks like a field access. That's actually the getter. So methods with empty parentheses, we can omit the parentheses when calling them. And there's no get or set prefix. And finally, we call the capitalized method on the string. Now, Java string doesn't have a capitalized method, but Scala has a mechanism that allows us to call utility methods as if they belong to the original class, making the code look nicer. And if we want to define copy ourselves, we can. So here we use def to specify that we define a method. The name is copy. It has two arguments, name, a string, and a default value, this name. So if we don't specify the name, the default value for the argument will be the group's original name, and same for the URL. So all that is left for us is to return this group. And return is optional in Scala. If we don't use it, then the result of the method is the last expression, in this case the group. Another thing is we have a mechanism for pattern matching, which allows us to write code declaratively rather than imperatively. So Java, we want to test if the group has a null URL. If so, we issue an error, and otherwise we print the group's details. In Scala, we have match, which is like a switch on steroids. So in the first case, we check if the group has some name and a null URL, and we issue an error. And if the group has some name and some URL, we print them. We can create our own match constructs called extractors. So here, in the second case, I check if the group has some name and a URL that comes from the tikalk.com host. And if so, I print, and otherwise, in the default case, an error. And you can imagine how the matching code, the similar code in Java would look like. Moving on to the first screen.
And I think we need like a baseline, maybe. What is Scala? What is it for?
Sorry. So Scala is a language that runs on the JVM. So Scala code compiles to bytecode, and you can call Scala code from Java or call Java code from Scala. So it seamlessly integrates, and obviously you can run applications written in Scala in Android. And basically it's a more advanced language that lets you do things more agile, more productive. So the first screen is the settings screen. The class diagram is that we have a settings activity, which extends list activity. And it uses a settings class to retrieve the list of groups that the user selected from the preferences store. So what is an activity? From the Android documentation, it's a single focus thing that the user can do, usually a controller of the GUI screen. We can create the view either programmatically, by creating objects, or from an XML layout. And the activity reacts to events when the user interacts with the screen. Many screens in Android show lists, so there's a special kind of class called list activity. It has some predefined views and a special event for when the user clicks on an item. To populate the rows of the GUI, we use a list adapter that converts a list of elements to GUI rows, usually by implementing the getView method. And the flow is we get our groups, we populate the list view using the adapter, we read the previously selected groups from the preferences store and tick those that match. And when the user clicks on an item, we tick or untick the item and save the preferences. To do that, we use the settings class, which is a utility class, because the preferences store can only store simple types, and we want to store a list of groups. So the setting class converts a list of groups into a string representation, and vice versa. Let's see how we define the class. So in Java, we have the settings class with two fields, and in the constructor, we initialize one field directly, and the other field, we get a service from the Android SDK. And here is the same class in Scala. So constructor arguments follow the class name, and inside the class body, we can reference them. If there's a need, the compiler will generate the field for us. And we define here a field, prefs. It's actually a property, so it's both a field and an accessor method. And we get the preferences store from the Android SDK. You may notice we don't specify the type of this field. By the way, it's val, so it's a final field. And the reason we don't need to specify the type is because we have type inference. So again, example in Java first. We read the string of the selected groups from the preferences store, and then split it with a comma. And even though the compiler knows that getString returns a string and that split returns an array of strings, we still need to specify the types explicitly on the left-hand side. So in Scala, we only need to specify the name of the variable. And if the compiler can, it will try to infer the type from the right-hand side of the assignment. So in this case, it knows that getString evaluates to a string, so it knows the type of settings is a string, and that split evaluates to an array of strings, so strs is an array of strings. This looks like a dynamic language, but it's actually statically typed. So if we try to assign an int now, the compiler will fail. So far we've seen that in Scala the compiler works for us, generating boilerplate code or type inference. I want to talk a bit about collections in Scala. So at the top you see the string from the preferences store, and we want to parse this string. So first we split with a comma, then we create a new array, and we iterate over the array and create a new element, setting it in the right index of the array. And what's wrong here is that this code conflates two things, the parsing logic and the iteration logic. So it's harder to read and harder to refactor. Before I show the Scala code, I want to explain a bit about map. So map is a method that when invoked on a source collection will create a new collection by accepting a function as an argument. The function f, in this case, converts elements from the source collection of circles to rectangles. And what map does is it creates the target location and then iterates over the source location, applying the function to each element and populating the target collection with the results. And this is how it looks in Scala. So first we split the string with a comma, and then we call map on the array of strings. We pass it an anonymous function. with a single argument setting, and again, because of type inference, because we invoked map on an array of strings, the compiler knows that setting is an argument of type string. In the body of the function, we split with the @ sign, and we create a new group instance. We don't need to specify to use new for case classes. And we also don't use square brackets for accessing array elements. Because this is the last expression in the function, this is a result of the function. So now the compiler knows that the function is from a string to a group. And so map, because it was invoked on an array of strings, will return an array of groups. And this is both at runtime and the static type. If we would now want to refactor our code so that everything will be done in parallel, all we need to do is use the par method. This will convert the array into an implementation of a parallel array whose mapping implementation invokes the function in parallel, gathering all the results and returning when everything is ready. And we can do that because we separated the iteration code from the actual logic.
How does it make it parallel? Using threads or a sync test?
Fork join executor.
Oh, okay.
And of course, it is very smart how it splits the jobs. And
could you talk about a bit about that? Because up until now, it's been syntactic sugaring all the way.
Yeah. So let me finish all the lecture, and then I'll talk about beyond syntactic sugar. Okay. About iterators. By the way, type inference is not syntactic sugar. Disadvantages when I implement a new collection. I need to implement the iterator class, so I need to create a new class, and the implementation of the class is not very trivial because the user may change the underlying collection while iterating, so I need to throw a concurrent modification exception, or the user may call next without checking has next first, so I need to throw no such element exception. So the implementation is not trivial, and also the client code is not safe because there can be runtime exceptions. In Scala we use for each for that. So we have a collection, a generic collection, and then we implement the for each method. It accepts a function. It's similar to map, but it doesn't return any result. It just first, this is a skeleton of course, it first checks if there are more elements to iterate, and while there are more elements, it fetches the current one, applies the function, and then checks for more. And below you can see the client code. So functions are a very useful thing. I like this quote from Steve Yeager. I won't read it because we don't have much time, but basically it says that in Java all we can do is use classes, and Scala provides functions as another tool for our use. Another feature of functions is inversion of control. Again, basic Java code, we get some input stream, we work with it, we need to remember to wrap this in finally close to close the input stream. Using functions, we can implement a with input stream method that accepts a function, and then the client code just calls with input stream, passing it the function, and inside with input stream will open the input stream and finally close it. So the code is more robust. The groups screen, back to Android, has a main activity. It extends this activity and gets the settings from the preferences store. And the flow is to read the groups from the settings, populate the list view, and when the user clicks an item, open the articles activity. Here's how we populate the view in Android. So we implement the onCreate method. We read the array of groups, and we set the list adapter using a groups adapter, which uses the simple list layout, which shows only a simple string, so it will convert each group to a string representation. The article string is where we see the list of articles from a group. The classes is the articles activity. It uses a field parser to read the articles from the Tikal community site, and an article adapter with a special kind of layout. So a layout in Android is an XML that helps us arrange widgets. It's inflated in runtime to a hierarchy of objects, and we can assign optional IDs to elements in the XML that we can use in our code because during build time a class with constants is generated for us, and we use the IDs to set properties of the widgets. Here's how the XML looks like. So we have it's a relative layout with I show one element, the text view, with an ID article title. So we'll have a constant article title, and we can use it to set the title of the article. And beyond syntactic sugar. Syntactic sugar is easier to explain. This is the more, we're now going into a bit more deep water. So our use case is that we have a feed parser interface with only a single method fetch for getting the list of RSS items. And what we have first, we have an XML parser which retrieves an XML from the site and passes it into a list. But for performance reasons, we also want to cache the results. So we also have an implementation caching parser. And what we want is our group parser to extend both of these classes. Of course, this is multiple inheritance. In Java, we can do that. In Scala, we have traits. So traits allow us to have multiple inheritance in code that is compiled to single inheritance in bytecode. So we get the benefits of multiple inheritance for our modeling, but during runtime, it's single inheritance, so we don't get the drawbacks. On the left, you can see a class using two traits, so it mixes in the logic inside the traits, and when this class is compiled, the trait implementation is separated into an interface and implementation class, and the compiler just delegates the methods from the class to the trait implementation. In our use case, we want to do something called stacking, which is sort of like aspect-oriented programming in code. So our feed parser has several aspects: caching, retrying, and maybe composing to read from several feeds. So first we declare our trait, feed parser, which has a single method fetch that is abstract. There's no implementation, so this is in fact just an interface. And then we have the caching parser trait. It extends feed parser, and it implements fetch, but it defines fetch to be abstract override, which means the compiler will make sure that when we use this trait, we also use another trait that provide a concrete implementation of fetch. Inside the method body, we merge the cached results with whatever super fetch on the right, which is the concrete implementation returns. We save this and return. And our group parser, this is how it uses it. So it has two arguments in its constructor. It passes the URL to the XML parser, which is the concrete implementation. And it also mixes in caching parser and retrying parser. And during runtime, when we call fetch, it will first go to the implementation in the retrying parser, which we'll call superfetch. This will go to caching parser, which will again call superfetch, as we saw, going to the XML parser, which will read and pass the results, going back to caching parser, which will merge the results, going back to retrying parser, and if everything goes well, going back to the client code. Other things we can do with traits is have additional functionality. For example, we can have a trait for observable that has methods and fields for managing listeners and invoking events. As an anecdote, Java has an observable class, but nobody uses it, because if you extend this class, then you can't extend any other thing. In Scala, we can have our class extending another class and mixing in this observable trait and maybe another trait.
So it's like a mixing in Ruby?
Yeah. And we can also have implementations that, based on some basic functionality, extend it. So a simple example, we have a URL support trait. It expects an implementation of a single method URL, and on top of this, it provides a URL string method and a URI method. URI is the Android equivalent of a URL. And in our group case class, because we have a URL attribute, we also have an accessor method URL. So it implements the method that URL support, and our group case class has these additional methods. Final feature is implicit arguments. This is probably the most powerful feature of Scala, and maybe the trickiest to understand. Our use case is that we need to match cached feed results with the current. So one way to do it is to use a sorting collection. So here in Java, a tree set, it has two constructors, an empty one and a one that accepts a comparator. And the compare method below, as you can see, is quite tricky. If we created a collection with an empty constructor, then there's no comparator. So it casts the first element into the comparable interface, and then uses compare to method to compare with the second element. And if there is a comparator, it uses its method. So the implementation is tricky. It can cause runtime exceptions, class cast, and it relies on two interfaces. So if we create our own class, we need to basically implement two interfaces in order to make sure it is usable in all situations. In order to explain implicit arguments, I first show a session of the Scala REPL. The Scala REPL is a Scala shell that is familiar to those that use dynamic languages.
Does it work on Android or is it just on your machine?
No. Well, maybe it works on Android. It's a Java application, but I don't know. I'm talking about my machine. So we can type in Scala expressions and they are compiled and evaluated on the spot. So it's a great way to experiment with code. Here I define an example method. And what's unique here is that it has two argument lists. The first argument list with S1 and the second argument list with S2. And the implementation is to just concatenate these two arguments. In the middle, we call the method with two arguments, and we go get hello world. In the third line, we try to call it with a single argument, and of course, we get a compile time error that it's missing an argument. So nothing much special here. But here I define an example again, but this time I define the second argument list as implicit. And now when I try to call example with just one argument, the error is different. The compiler says it could not find an implicit value. So let's define an implicit value. So I define an implicit an implicit variable named S with the value world. And below, when I call example with only hello, the compiler looks for an implicit variable matching the type of the argument, and it finds it. So as we can see, the result is hello world. So implicit allows us to have sort of like auto-wire dependency injection in compile time.
But having two parentheses is not a normal method call, is it? Normally you use the comma.
Yeah, it depends on you. You can use a comma.
If based on this definition I call example with hello, comma, something else,
it won't work.
It won't work.
No, because it expects two parentheses.
So now I need to know that the implementation of example is such that I need two parentheses,
yeah, sure,
as opposed to a comma.
Yeah. So if you work in an ID, it will complete it for you. Or it is also used to create a sort of like if you consider, for example, while, Java's while. So it has two argument lists, right? The first is the Boolean condition and then the body. Mm-hmm. So in Scala, you can create such a syntax using two argument lists. I want to first, complete the lecture and then I'll be able to answer any questions. So now we can show how sort works, for example. So I define a method sort. It accepts an argument of a list of elements, and another argument, ordering, which is like comparator, sorry, that is implicit. In the middle, I call it with a list of integers, and I get back the sorted list, because the compiler sees that I have a list of integers, so it tries to find an ordering of int, and it finds it. It's predefined in Scala. And of course, if I want, I can provide my own implementation, either by implementing an anonymous class or using some utility methods. And this is how the collection of tree set is implemented in Scala. So it has some arguments in the constructor and an implicit argument for ordering. It also has an empty constructor, which is defined using the def this that you see. And the implementation of compare is quite trivial, just calls ordering with the compare. And this is how we use it. I create a new instance of tree set for RSS items. I add to it the cached list of RSS items and the latest RSS items. You notice I use the ++ operator. It's not an operator that is hard-coded into the language spec. Instead, it's a syntactic sugar for a method call. So it's equivalent to this below. So Scala allows us to create methods that have that has symbols, not just alphanumeric characters. And this allows us to create our own operators. And if used with caution, it can help us write a better code, more readable, for the same reasons that math has invented the operators in the first place. The final piece of the puzzle is how we give the compiler the implementation of for ordering of RSS items. So in the top, I define an RSS item case class with a pub date attribute, and also an object named RSS item. So an object defines a single instance of an anonymous class. It's basically a global variable. In this case, it has the same name as the class name. So it has a special link with the class. It's called the companion object of the class. And when the compiler searches for implicit values of ordering of RSS item, it will look inside this companion object. And as you can see, it has an implicit value defined, ord, and you can see how it is defined. So when calling tree set with no arguments, it's exactly as the line you see below, passing in RSS item.ord. Again, what the compiler does is essentially dependency injection. So this was the last feature I wanted to show you. And comparing lines of code, so Java, the Scala version was half of the Scala one. The Scala version was half of the Java one. This is normal. Usually when we go from Java code to Scala, we get 2 to 3 times the reduction of code, which means, of course, less boilerplate code, easier to refactor, easier to code, etc. Here the feature we went over: case classes, named argument, default values, pattern matching, class definition, type inference, collection, traits, implicit arguments, operators, and objects. And here are the things we didn't go over. Yeah. So, of course, the question is Scala complex? So this is something I wrote when I first encountered Scala. Again, I won't read it. Basically, I found it complex. So it's not the question if is it complex, the question is it worth it? And the same question is it worth all the learning all the frameworks that we use in Java or otherwise, like Hibernate, Spring, Juice? And the answer is yes, because once we learn how to use a framework, we become more proficient, our code becomes better. Another analogy is an Android phone, because the Android phone is more complex to operate than a normal phone. My grandmother can't operate my phone, but still they are very popular. And the reason is that once we learn how to use them, we become more productive and find exciting new uses for them. So ask yourself if you want to stay with Java or switch to Scala. And I'll be happy to answer any questions. You had a question?
Yeah, my question was about the function definition. Like, is it like in Objective-C, so you can define function as sentences? So you can have do something X, that's the argument, and then do something Y, just another argument.
You mean like create a DSL?
No, like in C functions, you have the arguments as brackets, and in Objective-C, you can, if I know correctly, it's like you can have the arguments anywhere, and it's like a sentence.
Well, you can create sentence like DSLs in Scala, because of the fact that it allows you to use methods without the dot and parentheses, like I showed for operators. And there are some libraries that do it. So you can go this way. Scala was created as a scalable language. So a language where you can write DSLs. This is one of its strengths.
Domain-specific language.
Yeah, domain-specific languages. And so yeah, you can do all sorts of...
So it's just many parentheses.
Yeah, you can write many parentheses, or you can write, if you write many parentheses to do constructs like while. So we have while, something, and then another block. So this is what multiple argument lists are used for. If you want, to write code that is with spaces and not dot and parentheses, then you write methods that accept only one argument, and then you chain them. Okay.
What are Scala limitations?
What are Scala limitations? Well, every language has limitations. Basically, it's statically typed, so you can do all kinds of hacks. For me, it's an advantage, not a limitation, because once your code grows, you want to be able to navigate through it using the IDE. It's a very powerful language. The limitation is maybe because it's powerful, so it's complex, and you need to know to choose the right tools. If you go berserk and try to read all blogs and use whatever you see in a blog post, you'll get unmaintainable code. So Java tries to tie our hands behind our backs. Scala doesn't. So you have to be careful and more responsible.
Can you say about comparison to Ruby or Python?
So I know Ruby very well. I can't talk much about Python. So basically, Ruby is a dynamically typed language. So basically, it's easier for the language authors, for maths, to create such a language because it's not tied with, abiding by types. But for me, what I discovered is that it's easier to write code in Ruby, but essentially you have to keep the types in your head. And if you go after 6 months to a code you wrote, or I wrote, I need to recall what the type of the arguments were in order to know what methods I need to use. So
what about performance?
Performance? Scala performs like Java, sometimes better, because it has like lazy arguments that are evaluated only on need and stuff like that. Specialization, there's all sorts of features that help performance, but basically it's like Java.
I have a last question as a organizer. So what do I need to do to make it work with Eclipse right now? Like, I'm back at home.
Eclipse, so Eclipse or IDEA both have plugins. The Eclipse plugin is developed by the guys that are behind Scala. So it's right now the IDEA plugin is better, but Eclipse is, in my view, is better. But Eclipse is getting there. So you just install the plugin. And if you want to build the project, then Maven has a plugin for Scala, or there's a Scala build tool called SBT that is very good at building Scala code. So you can use that, and there's all sorts of archetypes to get the skeleton code.
Okay, thank you.